Hi, welcome to our first lesson in solving systems of equations with substitution. Cool? Yay, let's get started. All right, so we have solving system by substitution. So I want you to consider this idea. Consider if A, random letter, equals B, and B equals C, then what other statement could we make that's also a true statement, given these two situations? Hopefully, you're thinking A equals C. We can essentially cut out this whole middle section and just simply say A equals C. So we're going to use this concept of essentially cutting out this middleman, whatever this middleman may be, and we're actually going to solve some systems of equations using what's called substitution. In other words, we are substituting, instead of saying B here, because we know B is equal to C, we're just writing C right there. All right, so let's see this in action in a very simple way. What if we had this? So now we're going to consider, we have y is equal to 2x plus 1, and we have y is equal to 3x minus 4. Now, hopefully you're looking at these and saying, oh, they're in slope-intercept form. Awesome, I could graph them. And yes, you totally could. The thing is, solving by graphing, again, like I said in the last module, or last lesson in the last module, or in this last module, oh my gosh, what I was saying in the last lesson, last video, was that sometimes graphing is not necessarily the best solution method, because sometimes you can't be precise and you can't be exact. Sometimes you can make mistakes pretty easily with the visual. Sometimes you have to really expand it out. Looking at this, I have two fairly steep slopes and it could potentially get messy. So what we can do is what's called substitution. So just like in the last sort of scenario where we had A is equal to B, B is also equal to C, and so we could therefore say A is equal to C, because we can have that statement. And FYI, these three dots, like in a triangle, I don't know if you can really see that. That means therefore. It's kind of cool. Nice little shortcut jargon. Either way, we can use that same idea here. We have y is equal to 2x plus 1. And we also have y equaling 3x minus 4. In other words, I can create a whole new equation for this and say 2x plus 1 is equal to 3x minus 4. In the same capacity that we had this b here and we cut it out of the equation, we have y here and we cut it out of this equation and created one whole equation. So what's cool is if you have a system of equations, if you have two equations with two unknowns, x and y, the only way that you can actually solve them is by having two equations. So we have two equations, two unknowns, meaning we can actually find the solution of those things. The only way we can find the solution of those things is with various methods. We look at graphing, and now we're going to look at substitution, and we'll look at elimination in our next lesson. But this whole premise right here of cutting out this middleman is the focus of this entire set of solving systems by substitution. So we're not actually going to solve this. I mean, we totally could. We can subtract 2x on the other side and that sort of thing. We're not going to actually solve this one though right now. I just want you to sort of consider this idea of cutting out the middleman to find a solution. And we are going to watch, or there are going to be 3 other short videos. I'm hoping they're going to be short, with varying difficulty of substitution problems. We're going to start fairly basic, then we're going to get a little bit more complicated, and then as complex as I can possibly handle on a live YouTube stream. It'll be fun. All right, thanks for watching this quick video, and watch the next one. Bye.